Okay, in this video, we're going to talk about the relationship between factors and solutions. So, we've talked about factoring to solve quadratics and how we set those factors equal to 0 to find the solutions. Okay, so we want to understand what that means in relationship when you have a solution side by side with its factor. So, number one, these are all questions that come straight off Regents exam. So we're going to show you exactly how you might be asked about these questions and teach you the relationship directly through them. Number one, explain how to determine the zeros of f of x equals x plus 3, x minus 1, x minus 8. It's all multiplied together, okay, and to state the zeros of the function. So this expression, this function right here is already factored, okay? It was a quadratic at some point, okay? Or actually, it was a cubic because there's 3 solutions here, okay? It was to the degree 3, but it's all factored. So, how do you find the zeros of this? You set each factor equal to 0. Set each factor equal to 0. Let's do that. So we have to take x plus 3 and set it equal to 0 and solve. Well, I subtract 3 on both sides, and that is x equals negative 3, or the point negative 3 comma 0. Let's take a quick second and look at the factor and look at its solution. The factor was x plus 3. The answer is x minus 3. What's the relationship? Well, the factor is going to have the inverse sign of the solution because you're solving it. You're setting it equal to 0. You're moving it to the other side of the equal sign. You're doing its inverse. So I don't have to go crazy with my next factor. I just know it's the opposite sign or the inverse sign if I solve it for 0. So that means my next factor, x minus 1, if I set that equal to 0, that's going to be x equals positive 1. Because if I add 1 to both sides, I'm going to get positive 1. That's 1, 0. My third factor, x minus 8 equals 0. Well, if I move that, I'm adding 8 to both sides, I'm going to get the inverse sign of negative 8, which is positive 8, and that's 8 comma 0. So I've stated the zeros, and I know that because I set each factor equal to 0. Okay? The key part of that relationship was that it's the inverse sign. And this is true when x has a coefficient of 1. All of these have a coefficient of 1 for x. Okay, we're talking about this scenario. Now, here's another way you might be asked this question. It says in number 2, which polynomial function has zeros at negative 3, 0, and 4? So there's a few things I know from this. I know that this is actually going to be cubic or degree 3 because there's 1, 2, 3 zeros. All right. But if I needed to figure out what the polynomial looks like, I can find the factors from the solutions and then work backwards to get myself the equation. So if I have a 0 at negative 3, using what we just learned about inverse signs, okay, this factor would be x plus 3. If my solution is 0, then that means x equals 0, which is just the factor of x. And for positive 4, that would mean it came from the factor x minus 4. The opposite sign. So now I have, I'm going to write it right beneath it. I'm going to put the x in front. That'll help me. X times x plus 3 times x minus 4. All right, do I see any of those as options here? No, I see, yes, I do, just kidding. I see it. Where do I see it? I see it with letter C. So that's my answer. Okay. How did they get answers A and B? Well, they took the x and they would have distributed it to the first factor. And you could do that. That would also be equivalent if our answer wasn't here. Okay? How do I tell a polynomial from a graph? It says which function could represent this graph. They're giving me an image and they want me to find the equation. How do I do that? Well, look at the solutions or look at the zeros. Okay? Where is the graph crossing? It's crossing at 3 spots. I can pick those 3 spots off the graph. I know these values. Okay, I have a 0 at -2. I have it at 1 and at +2. So if my zeros are -2, 1, and +2, what are those as factors? Take the inverse signs. Well, x plus 2 times x minus 1 times x minus 2. If I set each of these factors equal to 0, I would get the solutions written right above them because they're the opposite signs. So now, do I see x plus 2 times x minus 1 times x minus 2 as any of my answers? No. I see they simplified it a bit further. So we have to try to multiply ourselves and see what we get. Well, look at A. A is x plus 1. So x plus 1 was left untouched, which means the other two factors, x plus 2 and x minus 2, were multiplied together. So let's multiply them and see what we get. X times x is x squared. X times -2 is a -2x plus 2x minus 4. These will cancel out, and I'm left with x squared minus 4 times x plus 1. Okay, is that the answer for A? No, they don't match, so A is not my answer. Do I see this answer anywhere else? Yeah, I actually see this answer in letter C. Oh, I'm wrong. Letter D, I'm sorry. No, nowhere. So that means, what did I do wrong? Oh, I know what I did wrong because this is an x minus 1. I wrote the problem wrong. That first factor should have been x minus 1. So you see how I wrote plus? Let's change those to minus. You always got to check your work. Always, always, always. So let's fix it. This purple factor, why isn't it erasing? This purple factor should read x minus 1. So now let's ask ourselves, do we see x minus 1 times x squared minus 4? Yes, and that's C. Okay. So we left out the x minus 1, and we multiplied the other two factors to get the expression x squared minus 4, and that's going to give us C. F of x equals x minus 1 times x squared minus 4. So the relationship between zeros and factors is that we can use the solutions to work backwards to get factors using inverse signs. Then you multiply your factors to get your quadratic or your cubic, whatever type of function this is. But you can very well do this. And let's do number 4 together. It says the graph of the quadratic equation is shown in the accompanying diagram. The scale on the axes is a unit scale. Write the equation of this graph in standard form. That's all they've given us. So I know it's going to be a quadratic because I'm looking at a parabola, a U-shaped graph. How the heck am I going to get its equation? Well, I need to grab its zeros off the graph. What is one of the zeros? Let's count where this is at. -1, -2, -3, -4, -5, -6. So that 0 is x equals -6. What is that factor? That factor is x plus 6. It's the inverse sign, x plus 6. If I had set that equal to 0, I'm going to get back x equals -6. What is the right solution? That's at 1, 2, 3. So if x equals 3, what is that factor? Well, the inverse of positive 3 would be -3. So that came from x minus 3. If x minus 3 was set equal to 0 and solved for x, you would get x equals positive 3. So now I have these two factors. They need to be multiplied so I can get back the quadratic equation. These are just the factors, so we're going to multiply. We're going backwards. So let's take x times x. We get x squared. X times -3, -3x. 6 times x, positive 6x. 6 times -3, -18. Combine your like terms. We have x squared. -3 plus 6x is positive 3x minus 18. And that is my quadratic. Okay, if we set it equal to 0, we get the solutions. If I want it as a written equation, I can also write y equals x squared plus 3x minus 18. This is the equation of this quadratic. Okay, so the relationship between zeros or solutions and their factors is that they are the inverse signs. That is a really big, important fact so that it can get you to understand the relationship between graphs and equations and how to go back and forth between the factored form and the solutions to get you the original equations. Okay? This worksheet has left 2 problems, 5 and 6. You will complete those on your own using this video.